All right, let's dive in. Today, we're going to go on a little journey to see how modern web apps are actually built, piece by piece. We're going to look at the essential toolkit that developers use to take a simple idea and turn it into the powerful apps we use every single day. You've probably wondered this, right? You start with a totally blank screen, and somehow that becomes this rich, interactive thing. So how does that actually happen? It's not magic, I promise. It's all about using the right tools in the right order. So let's start at the very beginning, a blank page. To make it do anything at all, to make it come alive, it needs something like a nervous system. But before we get to the nerves, we've got to build the body. And that body is made of two things. First, you have HTML. That's the skeleton. It gives the page its basic shape. You know, the headings, the paragraphs, where the images go. Then you have CSS. That's all the style. It's the clothes, the paint, the design that makes it look good. But right now, it's just a static model. It looks nice, but it can't do anything. And this is where our nervous system comes in. JavaScript. It's the third pillar of the web, and it's the one that brings everything to life. JavaScript is what lets the page actually respond to you. When you click a button, fill out a form, or just scroll, that's JavaScript at work. So how does it pull this off? Well, JavaScript has this incredible power to directly change the page's structure while you're looking at it. This live structure is called the Document Object Model, or the DOM for short. By tweaking the DOM, JavaScript can add, remove, or change any piece of HTML or CSS on the fly. It's what makes the page feel dynamic.
Now, this direct control is awesome for simple stuff, but think about the apps we use today. A social media feed with endless updates, a live stock tracker. The data is constantly changing. Trying to manually tell JavaScript exactly what to change second by second, well, it gets complicated fast.
The folks behind 30 Days of React really hit the nail on the head. They said it's not very convenient to have to update everything by hand whenever your data changes. And that's an understatement. It's not just inconvenient, it's slow and a recipe for bugs. There has to be a better way, right? And that better way is React. React is a JavaScript library that totally changed the game for building user interfaces. The big idea here is, instead of building one giant monolithic page, React lets you build it out of tiny, independent, and reusable digital Lego bricks. It's a brilliant way to manage complexity. In the React world, these Lego bricks are called components. A component is just a self-contained piece of your user interface. Think of a search bar, or a user profile, or even a like button. Each one manages its own business, its own data, and its own logic. You build your whole app just by snapping these components together. It's so much more organized. So what's React's secret sauce? It's this amazing thing called the virtual DOM. Remember how we said changing the real DOM directly is slow? React has a clever workaround. When data changes, it doesn't touch the real page. First, it updates a super fast copy of the DOM that lives only in memory. Then, it compares that virtual copy to the real one, figures out the absolute smallest change required, and only then does it update that one tiny part of the real page. It is incredibly efficient. Okay, so now we've got this powerful, well-organized app. But as our code gets more complex, it just gets easier for bugs to sneak in. That's especially true for a language as flexible as JavaScript. So how do we build with confidence? How do we add a safety net? Here's a perfect example of how JavaScript's flexibility can sometimes be a problem. Let's say you have a function that's meant to square a number. Simple enough. But what if you accidentally give it the letter Z instead of a number? JavaScript doesn't complain. It just runs the code and quietly gives you back NaN, which means not a number. You might not even notice this bug until it's out in the wild affecting real users. And this really highlights the huge difference between dynamic and static typing. With JavaScript's dynamic style, you often find these kinds of type errors only when you actually run the code. But with static typing, it's like having someone check your work as you write it, catching those mistakes before they can ever become a problem. And that's exactly what TypeScript gives us. Now, it's not a whole new language. It's what we call a superset of JavaScript. That just means it's all the JavaScript you know and love, but with one extra feature: types.
The best way to think about it is like a superpowered spell checker and grammar checker for your code. So with TypeScript, you're just a bit more explicit. You tell your function what you expect. Here, we're saying the add function needs A to be a number and B to be a number. Now, if you try to pass it a string, your code editor will light up and warn you immediately. It's a safety net that catches so many potential bugs right then and there.
Fantastic. Our app is now powerful, organized, and safe. But let's be real, software is never built by just one person. And it's never really finished, is it? It's always evolving. So how do you manage a whole team working on the same code without it turning into total chaos?
The answer is Git. Git is a version control system. And that's just a fancy way of saying two things. It's a time machine for your code, and it's a collaborative blueprint for your team. It lets you rewind to any point in your project's history and makes it possible for lots of people to contribute without stepping on each other's toes.
The way Git works is by taking snapshots of your project. We call these commits. Every time you make a set of changes you're happy with, you create a commit. You give it a little message describing what you did, like added user login. Over time, this creates this beautiful, detailed history of your entire project, from day one to the latest launch.
The basic workflow is actually pretty simple. First, you use git add to choose which changed files you want to include in your next snapshot. Think of it like putting things in a box. Then you git commit them, which seals the box and puts a label on it describing what's inside. And finally, you git push, which sends that box to a shared central place where the rest of your team can access it.
So when you put it all together, you see how everything fits. JavaScript is the action. It makes things interactive. React is the organization. It lets you build with components. TypeScript is the safety. It catches your errors. And Git is the collaboration. It tracks history and lets you work as a team. This is the core toolkit for modern web development.
So there you have it. We've gone from a completely blank page to a sophisticated, safe, and collaborative application, one tool at a time. You now have the blueprint for how it's all done. The only real question left is, what are you gonna build next?